Hello, everyone. Welcome to our weekly gathering for SIG Autoscaling. We are part of the Kubernetes project and the CNCF. We abide by the code of conduct, which can be summarized as be kind, respectful, and inclusive. Raise hands before speaking, and we'd love to hear from all voices. All right, without further ado, we have a couple of agenda items today. Maybe a brief pre-agenda announcement. Kubernetes 134.0 is live. So I don't have this as an agenda item, but I will. Oh, I see Adrian's got a question about VPN, so we can talk about that with that agenda item. But just PSA, go get your 134s. All right, Mike, you want to take it away?
Yeah. And I have a little slide deck to help illustrate this problem
Okay, cool.
if it's cool if I
Let
share.
me know if I'll stop sharing, and then do you need me to give you a host? Let's see.
Yeah, I did not.
More make co-host.
Okay, looks like it's working. All right. So this is an issue that I had brought up, and hopefully you're looking at the issue right here.
Yep,
Um,
looks good.
this is something I had brought up a couple weeks ago, but it's something that we've encountered, and I think we've nailed the bug down at this point. Essentially, what's happening is there's a possibility for nodes to, for expansion to not happen in certain scenarios. And I put together this slide deck here just to show how this works basically. So this is like a starting state of a cluster, right? You've got one workload pending, we've got the cluster autoscaler running, and we've got two node groups. One of them, the workload does not fit there, so it's not going to try to expand that. And the other one, it would fit onto node group two, but for whatever reason, node B is unschedulable right now. So what currently happens inside the cluster autoscaler is that when it attempts to do a scale simulation, it tries to observe the nodes that it thinks will be able to expand. And when it takes those nodes and it puts them into part of the scale simulation that says, okay, when I want to make a node template for this, how do I evaluate the nodes? First, I look to see if there's a node that I can use to compare against, and node B, would get, well, I'll get to that next, but like node B doesn't even make it into this list. But first it looks to see if a node is there. So it finds node A. Node A doesn't match the scheduling, so it gets rejected. If it could not find a node, right, it would go to make a node template for each node group. And then if it couldn't do that, it would try to make a sanitized node, a node that would otherwise be unschedulable, but it would make it unschedulable. So this is what's happening currently. And part of this, it never observes node group two because node B is pruned from the list of nodes that could be evaluated before it goes into the scheduling simulation. So node group two is never selected as a possible expansion. And what this should look like is this. It should be able to evaluate both sets of nodes. It would pick node A, from the node, and it would say, okay, that doesn't work, so I'm not going to simulate that. And it would drop through to the sanitize node option to pick node B and thus be able to find node group two. Now, I realize that I probably didn't explain this very well with these slides, and there's a lot to be desired here. But what I have done is gone through all the code that does this. And so this is, we can see at the last resort of the processor for the node info is to try to find unready or unschedulable nodes and see if those would be a good template, right? And so it goes into this little loop here and it tries to see if would it be a good node template. And if we look in the good node template here, one of the things it does is it tries to reverse the unschedulable bit. So it says if it looks for the readiness state. So this checks the conditions to make sure there's no conditions that would make it unready. It checks to make sure that it's stable. Then it checks to see if it has been set as unschedulable, and then it checks to see if it's going to be deleted, right? So if it's stable and it's ready and it's not going to be deleted, but it has been marked as unschedulable, right? it would be able to be processed by this and say, okay, I can use that as a template for a node. But if we look at how this function is called, the function where this happens, we can see this is happening in the run once. We can see that what's being passed in here is a list of ready nodes, right? And so if we look, how are those ready nodes determined? It's determined by this call here that says obtain node lists, and one of the outputs is the ready nodes. If we look at how those are generated, they're generated from a ready node lister, right? And that's using this is node ready and schedulable filter function to filter all the nodes into this list. And if we drill down into is node ready and schedulable, we can see that one of the things it looks at is the spec unschedulable? And if it is, it returns false here. What this means, though, is that this, this clause here would never be able to work for a node that has simply been set as unschedulable because it will be pruned before it ever goes into the list. And Jack, I see you got your hand up, please.
Adam was first, actually.
Oh, cool. Yeah, sorry, it's not showing up for me. Whoever's
Yeah,
first.
I think it is covered, but you are actually talking about the node being unschedulable, not the pod
Correct,
being
correct.
unschedulable on the node.
Yeah, there
Yep.
is it. There is, there's a field in the node spec that the user can set as, to true as unschedulable, and then that makes the node unschedulable, basically.
Yeah. Okay.
So I think as I'm reading through the code and listening to the explanation, it seems like the foundation of this as a proposal to change is that unschedulable properties on a node are not durable properties on the node group, but they're ephemeral properties of, you know, one or more singletons within that set. But we're treating it as if it's a durable node group property. So we're essentially, I mean, you're demonstrating the single node situation. I'm not sure what if there were a node group with a mixed set of nodes, one or more
Yeah,
of which were unschedulable, one of which was, would this
this wouldn't happen. Yeah, this wouldn't
I
happen.
see.
This
I see.
only
So it's
happens when
as it
all the nodes,
traverses
right.
one of the checks to determine whether or not to include a node group as the foundation for a template to consider for scheduling in the simulation is that all nodes aren't unschedulable, if that makes sense.
That does. Yes, you said it correct. I know you had to like work the logic out there, but yes, you said it
Yeah.
correctly. It
Okay, cool.
like so. Now the problem here, right, or the further problem, right, is I've gone back to the 1.23 release and like I'm still going back in time to learn more about this, but like for at least 10 releases, the behavior has been the way I'm describing it here. It has not been working. So I'm investigating some possibilities now because I'm working with a customer who's having a bug related to this, right? And I'm trying to figure out like what are the best ways to fix it, right? Now, this is where I run into some, I guess, philosophical questions for the SIG, right? Which is like this code here has been in the autoscaler for a very long time. And it seems like at one point the intention was that if you can't find a node that is schedulable, if you can't make a node template for the node group, then the last resort you should do is to look for a node in a node group that is somehow unschedulable. And if you made it schedulable, would that fit the
Yeah.
expander, right? But because so long ago we changed this, the ready node lister, I don't,
The inputs to that function are
it's never going
have
to see.
essentially been short circuited. It's never going to see an unschedulable node. So
Right,
the only sort of reasonable inference is that that was introduced after these first two chunks that you're showing here, but done so in the wrong order. Like it wouldn't
right,
make sense otherwise. Wouldn't make sense to do that. The
right,
only way to make sense would be if there were like a sane reason to do this, then you could have introduced that additional thing. And then in that second function is node good template candidate, you would remove the schedulable conditional evaluation because it's no longer relevant.
right,
Like we're
right.
wasting cycles there.
Right. But if all the nodes in a node group were unready, it would still not work either, right? So like there's a lot of weird cases here. And so to get to the kind of what I'm investigating now, what I'm trying to do is I'm actually investigating a couple ways that we might be able to fix this. One of them is like, could we just pass all the nodes? Could we create a separate parameter, pass all the nodes into the processing function, and then when we get down, if we fall through to this logical case, then instead of just checking the ready nodes, we should check all nodes here, right? And if a node is unready, belongs to a node group, we could use that as a possible template. I don't know what kind of that might have weird knock-on effects that I just don't know about yet. I'm still trying to learn that. The
Well,
other,
the unreadiness could be, it could go either way. I think unschedulable is fair to say that's it's very rarely going to be a property of the node group, but unready could be a property of the node group for reasons like maybe there's a pathological daemon set. So maybe you have a daemon set whose job is to prime a particular one or more particular node groups, and that daemon set's pathological, and so it's not making forward progress. So in that case, the unready state of one node in a node group is actually predictive that you add a new node, it's still going to be unready. I think that's
right.
a more predictive property compared to unschedulable.
Right. So like the other option that I was going to do was like to create a new list processor that finds all the nodes that are otherwise ready but are just marked as unschedulable, right? And then create that as a second list that can be passed into the processing function. So you have the ready nodes, and then you have the ready nodes that are just marked unschedulable. So they're not deleting, they're healthy, but they would otherwise not be schedulable, and that could be for whatever reason, right? But the prediction is that if you made a new node in that node group, it wouldn't just be unschedulable right off the bat, right? Now, I'm still not sure that this is the appropriate thing. It might be that what we say is that the cluster autoscaler was never meant to work this way, and that if you have no ready nodes in a node group, or you have no schedulable nodes in a node group, that the autoscaler is not going to consider that node group. But I'm not sure what the intention was. It seems like the intention was to allow a situation where all the nodes are unschedulable, but otherwise ready, and that should allow the cluster autoscaler to continue to expand that node group.
Yeah, I can help you with that investigation. Hopefully, it's more or less in the historical record. The likeliest is that someone made a change at some point and didn't even consider that they were changing this
Right.
behavior. That's I think fair enough to conclude that it wasn't intentional to override the
No,
original
yeah.
behavior.
So I'm trying to go back and do the engineering history now to figure out like where this bifurcated basically. But we've had over the last 10 releases, we've had some really great refactoring going on and everything. So there is kind of like a bridge in time when like we weren't handling the mixed node processor in the same way that we are now. So it's just taking me time to go back, but I am actively testing both of the 1 and 4 options on here to see like is there a way that we could work around this. I mean, the other the other solution to this is to always make sure that your node group can create a node template, right? So like that's the other solution to this. Most providers are pretty good about that. And this happens to be happening in cluster API. And Jack, you may remember some of this, like because of the way we've defined the scale from zero contract in cluster API, you don't necessarily have to implement scale from zero. And if you haven't, we have no way to make a node template for that node group, right? And so if you had a node group and you marked all of the nodes in that node group as unschedulable, and we couldn't make a template for it, this is going to happen, right? And so
Right.
like,
I mean, so you're saying we could actually, one alternate approach would be to uh, inject scale from zero in the flow of what you've been describing. Is it possible to fall back instead to a scale from zero? Like, okay, well, I don't have any nodes, operative nodes that I can use to form a template from, but is there scale from zero metadata? Would that be another way of dealing
right.
with this?
That is the other fix, right? And I should
Yeah, I
probably
see.
add that. I mean, there's no real way to add it to the possibilities here, but like because the contract from core autoscaler to the provider is that you're allowed to say, I don't implement node template info, right?
Yeah.
So if you don't implement it, there's no way for the core to make a template for that node group, right? So it's like, okay, what we could do is we could acknowledge the behavior that's been happening for the last dozen releases, and we could just add more information that says, look, like if you don't return, we just acknowledge that this happens if you can't return a node template, like we can't require everyone to return node templates because you might not be able to.
Yeah.
So I am like super curious to hear from anybody who has opinions on like what the proper fix here should be, or maybe it just requires more investigation at this point.
Yeah, I think based on the investigation, we should come up with at least one good solution.
Okay. I'm probably going to investigate, like now that we've talked about this, I'm probably going to keep going on option 4 here because I think it has the least potential for damage. It's going to make things a little more complicated in run once, but I feel like if we do this, we know we're not including nodes that would otherwise be in weird states or whatever. We're just pulling out everything that would otherwise be considered ready, except for the fact that it's got unschedulable, marked
Yeah.
as false or something.
So essentially the fallback goes into the input. The fallback list of nodes goes into the input and gets taken away from the sort of like end of execution flow.
Right, exactly. So if we look at like so the way this code works is that and I guess I can grab it here too. I can show how. So we're looking at this is the run once, and apologies if this is too small. I'll try to make it a little bigger there. We're looking at the run once function inside the cluster autoscaler, which runs once every whatever, every scan interval. And so what I'll have to do is I'll change this obtain node list to add an extra return here, the like ready, like unschedulable nodes, right?
Yeah.
And then we come down to where does it happen? Here. Here, we'll have to pass in an extra set that says these are the unschedulable nodes, right? That will end up coming into the process function here. And I won't change any, these are the checks. Like first we check the nodes to see, what's going on. I'm not going to change any of these. All I'm going to change is the last resort, and I'll have it
So instead of
use,
enumerating through that local variable, you would enumerate through the unschedulable nodes that was passed in.
right. And
Yeah.
we would only use the unschedulable nodes if we drop down to this last, fall through case or whatever. So that's the approach
Yeah.
that I'm probably going to explore.
The advantage of doing it the original way that somehow got broken is that you're only doing that composition if you need to. And so there's a little bit of extra cycles wasted for every single
Right.
interval.
Yep. It's going to
Yeah,
make
we can
things
get into all that detail as you get further.
right. The
Thanks so
thing is,
much
like,
for tracking this.
yeah, well, yeah. The thing is, I can also I could take the output of all nodes and filter them or something. I don't know. Like, I'll try to not make it too gross, but it's gonna be gross. It's gonna be big O of and
Big
two
O of
two N or something like that, or
hmm.
Okay, so yeah, that's that. Thank you for coming to my TED Talk, and I'll hand it back over to you, Jack.
All right. Yeah. Thanks so much, Mike. And pass along thank you to the customer you're representing for bringing this up. Okay. All right. Adrian, you are asking about VPA 1.5 now that
Yeah.
134 is out.
Um, so I don't know who has the ability to cut releases, but I know Louise. I think they're currently doing the 1.4.2 release. They could potentially do 1.5. I also don't know if there's any features we're waiting for pull requests that need to go into 1.5. I think all the big impact ones are in. So I guess if there's no objections, we should get it done.
Yeah. Okay, and I will drive a 134 release of CA. We don't have to wait this release. I'll prioritize that over patch releases, but we're also definitely due for some patch releases. So, and as I've said in earlier meetings, I've been working in the background when I have some spare cycles to try to reinforce the way we automate releases so it's a little bit easier.
Thanks for doing that. And I think Louise would also probably appreciate, because he's busy going through the pain of 1.4
Yeah.
point whatever.
All right. I'm just gonna quickly open up stat here. All right, cool. Anyone want to take advantage of 6 more minutes in the schedule to raise any ad hoc agenda items? Going once, going twice. Okay. Thanks, everybody.
Cheers.
See you
Thank
folks
Thank you,
next
everyone.
week.
Have a nice weekend. Bye bye.